if you guys
Yeah.
yeah.
Yes.
I hope you had some time to really think a bit about why and how we have used this method. Remember, we are finding the density of the solid. Again, maybe just what I can say about physics, like I always try to mention, is that there's no one way of doing things, but one thing that should be clicking in your mind is never look at a question as if it is hard. Even this question that we are looking at is not hard. It's just a puzzle. It's building up one thing. On one layer, you build up, you put another layer, you put another layer to get to where you want to go. Even these people who build houses, they don't just put a roof on top there, no. Sometimes you need to dig down, you put a foundation, you put the whatnots, all that's required. So even all that we have been doing, we found the buoyancy force, we found this. You should have just an end goal. You should just be asking yourself, I have this information. Can this information take me to another level? Okay. So I had the information. I knew that it can take me to finding the buoyancy force. If I find the buoyancy force, I divide it by the specific weight of the liquid. I can find the volume. Which volume am I finding? Since this solid was submerged in the water, meaning the volume that I'm finding here is also the volume for the solid, because the fluid of the liquid displaced is equals to the volume of the solid, and the volume and finding the volume by dividing the buoyancy force, by specific weight, I got the volume. And then I also know that density of the solid will be equal to that same volume, where I'm saying mass of the solid divided by that same volume. I was given the mass of the solid in air. So I can get the mass of the solid in air divided by the volume. I get the density of the solid. And this is how come we have found it to be this value here. Are we okay on how to go about this?
Yes.
So let's continue the last section of today. And the last section of today is just talking about the density of another liquid. All right. We were given in the question to say, find the density of another liquid in which the same solid would float. So the same solid which we are dealing with here is this solid with this mass. All right. Now we're not going to consider this part because this part was in this liquid which we are from solving. But this same solid which weighs this much was put in another liquid. Now in that other liquid, we have been told that one fifth of its volume was exposed above the surface. When we place this same solid into another liquid, we found that 1/5 of its volume was exposed above the surface. Now, what does it mean here? So let me, even Mr. Wisdom asked again that he didn't understand it properly. So let me try to explain it again by drawing, say we have a basin like that. And then we have the liquid level is like that. And then we have been told that there is a solid like that. We've been told that 1/5 of the volume is above the solid surface. What volume would be inside the liquid? Mr. Wisdom, what volume do you think, if we have on top, it is 1/5, what will remain under the solid, under the liquid here? What will remain? Mr. Wisdom.
Sir, unless you want me to guess. I don't know how to come about it.
Okay.
The 4 or 5.
Okay. Now, Mr. Wisdom, do you know why?
Yes.
Do you know what is meant by 1/5?
1/5.
1/5 or 1/5. What is what?
Not sure.
Okay, what is meant is, for example, if you have 5 oranges, all right, 5 oranges is what you have in the basket total. If someone gets 1 orange,
Yes.
all right, meaning that person has gotten 1 over the total 5 of the oranges, not so?
Okay. Okay.
Hmm?
I've gotten its probability.
Yes. And
Wow.
meaning
I've
what we have
gotten it.
remain is 4 over what? What we have is 4/5. What will remain is 4/5.
4/5. Yes.
All right. So if on your quiz mark I wrote on your quiz marks, if I wrote 5, you got 5/10, meaning the other part which you didn't get was also 5/10. All right.
Okay.
This is simple mathematics. So if they say 1/5 of it is exposed, meaning the one which is inside is what? 4/5. Just this is 1/5. What is remaining is 4/5, like that. And then, so now, because remember, even what I've said is that volume submerged is 4/5. All right. So since the volume submerged is 4/5, Simbarashi asked to say what condition are we going to use to say that buoyancy force and the weight is equals to 0, because this is the same as saying buoyancy force is equals to the weight. What condition do we need for it to be so? If this solid is not sinking, this solid is not here, it is floating, even if just a section of it, just a small portion of it is on top, it is still floating. So only when the solid is floating do we use this condition, and we have used it here. All right. Here we used a condition to say that buoyancy force, since it is not floating, it is sinking inside there. We said buoyancy force will not equal the weight, but it will equal the weight minus the weight of the solid in the liquid. In this case, there is no weight in the liquid because it's floating. Of course, there is some portion of it here, but we will not consider it because we have been told it's floating. So now, how do we express this? All right. Remember, we said that for us to buoyancy force, we can also express it as density of the liquid multiplied by the volume submerged, or the volume of the solid the volume of the displaced liquid multiplied by 9.8. All right. So, and the displaced liquid will be equal to the volume of this solid, which is inside the liquid. So the volume of the displaced liquid will equal this part which is under this liquid. No wonder we've gotten the 4/5, all right, to compute buoyancy force. But here, when we get, also, we said we can also compute the weight of the solid. Even the weight of the solid, we can also express it in terms of the density of the solid multiplied by the volume. Here now we are not saying 4/5. We are saying the whole volume of the solid multiplied by 9.8, and according to this equation, this is supposed to give us 0. And this is why we have 0. But again, we can simply cancel gravity here and there. Even this V, we can cancel it out because it's appearing throughout the equation. What will remain with is this equation. All right. So What are we looking for here? Find the density of another liquid in which the same solid would float 1/5. We are looking for the density of what? Another liquid. So we are looking for this guy here. We already found this. We found the density of the solid, remember? Which is this part. Now, here we need to find the density of this other what? This other liquid. Find the density of another liquid. And this is what we find here, right? Density of the other liquid, density of the solid which you found here, multiply by 5 divided by 4, you get this answer. Are we okay now?
Yes.
So have you seen that physics is a beautiful subject, beautiful course, beautiful field, where you just have to involve your faculties, your cognitives. And after that, you get your answers. So are we okay with the explanations?
Yes.
Yes, sir.
Okay, I'm tired of talking.
But sir,
Yes.
I'm a little bit behind on how to find what specific weight. Specific weight.
So specific weight, my
Just
brother. Yes, specific weight is as you get the density multiplied by the acceleration due to gravity. Density, anything. If you are finding the specific weight of a liquid, specific weight of that liquid is just density. Its density multiplied by acceleration due to gravity. You get it. See, specific weight.
All right.
Okay. Are we okay? Are we okay so far? Where we have reached? Everyone is everyone fine?
Yes.
I'm okay.
Yes.
Okay. So if you are okay, you say I'm okay. Then the person who will not say I'm okay will give a question. So is anyone who is okay with the explanation, say I'm fine.
Yeah, me, I'm fine. Yeah.
I'm fine.
So Chipo, you have not said whether you are okay or not.
I'm okay, sir.
Okay. I know some of you guys, your network was not okay, but I'm planning on uploading these videos. You can still watch them on YouTube. And I'm also going to send you these notes. Plus, there's a homework which I would be happy. I would be happy if you would finish this homework. It's just a small question. If you do it tonight, you know, by 2021, you send it, it will be good. So there's a homework here. I want you guys to solve it. And so see you next time. Have a wonderful afternoon.
Thank you.
Yeah.
Okay. Thank you.
Yeah, sorry, Precious. I think your network was tripping. But I guess you may watch the video if there's some part that you didn't see. Precious, are you there?
Yes, okay, I'll do that.
Okay, see you when you see me next time.
Right, see you.
Awesome.